Hello, YouTube. How are you today? Good. Let me just put my stuff around. Let's see if the stream is running. Okay, my water, keyboard, and I think it's up and running. Great. So today we will be answering data engineering questions. If anyone will ask any, I will be more than happy to answer. Or I will just use ChatGPT generated questions for me, so this would not be fully empty. Let me just put the camera a little bit. Okay, I think this looks good. Okay, so perfect. Let's go. So I would just go with the next question. But I would like to here to get more of design, infrastructure design questions. I don't know. Let's go with the next one. I'm pretty sure I will not be able to answer all of them. Okay, so the SQL. How would you write the SQL query to find the second highest salary from the employee table? Take your time. Okay, so I think this one is easy, right? Select star from salaries. Limit order by salary. Limit 1, 2. I believe that's the case. Something like that. Would that work? MySQL limit offset. That should have, right? It has a limit. Okay, but this will not be going with this one, right? What we want to do, we want to actually do something like, okay, want to get row having row number equal 2. Would that work? Let's limit this one to have only 2 results, and then let's select everything from the subquery where row number where R number is equal to. Would that work? Right, we need to partition those. So what was the correct answer? So yeah, so alternatively you could go with just selecting the maximum salary and selecting, but like we need to get the Yeah, that's true. That's interesting approach. Okay, let's go next question. Oh, Python data science. You have given a list of integers. Write a Python function that returns the sum of the squares of only the even numbers in the list. I don't know. Oh, okay, we're practicing, right? So let's practice. So you're giving a list of integers. Write a Python function that returns the sum of squares. Okay, let's do that. Let's write the function. So let's create a new project. Let's call it actually, okay, so new project. No, I don't like this one. Okay, let's go here. So let's go to our projects. Let's create questions. Perfect. Now let's go into projects, select questions, open. Yes, that's the project. Let's also Python 3.12 minus m env.env. Close. Okay. Now we have the environment in here. Let's go to the project structure. And now let's select a custom Python SDK with the already predefined bin Python. What did I do? I have, oh, shoot. I created virtual environment in the root directory, not in the projects. Bin Python, that's good. That's good. Let's apply, perfect. So Python file. Q1. Okay, so what they asking for? So let's go def. Is this a correct answer? So this is how useless this question is. Because, I mean, would I be able to write something like that? Most likely, for some time. I mean, I don't really write this often, these functions, so it's sort of like very hard to, you know, to sort of like have all of those in mind, right? Like, but then the moment I go here and put there and basically just start writing, I'm getting the function given to me, right? And then this is an accurate function. I want to have a sum of the, you know, like square numbers where these numbers is here, and this is cool, right? So we can do sum of numbers, and then we provide just numbers, you know, like that, and then we can just run Python question 1. And why not working? Line 3. Oh, because of, right. Because of all of those. Right, line 3. Can just get rid of all of that. And of course we need to have print the results. And we have the result. So if we go 1, 2, the answer should be 4. Yes. And then if we go additionally 2, the answer should be 8. Yes, so that's correct. Next question. This is interesting. I think it's an interesting concept of like, what's the purpose of asking all of these questions if at the end of the day you can just, in pandas data frame we call them sales, write a code snippet to calculate the average of the sale column while ignoring any missing values. Right. So now if I go and that's it. It's so it's not even interesting. Right. Next question. Is this called cheating? Because at the work, you just need to do the work. You don't really, doesn't really matter, how much time does it take. Like, well, actually, like the faster you can do it, the better it is. Okay, question, data modeling. Imagine you asked with designing the database scheme for the e-commerce platform and to store information about customers, products, and orders, how you would model the relationship between these entities. Feel free. Okay, so this is interesting. So you needed to store information about customers, products, and orders. Customers, orders, products. Okay, so let's try this. I would create following tables: customers, products, orders, order items. Now, okay, so following customers, okay. Now let's go further. Okay, let's go further. So additional, what I want to do, I want to have the order items. Order items will have a relationship with orders and products. Okay. Orders will have relationship with customers. I'm going very simple on this one. I'm not going into the details. Right. Customer table, primary key, product, right. Order table, foreign key, or yeah. or order ID, relationships, and then product, and the schema diagram, customers, orders. That's interesting. I like this approach. Product ID and orders. Yeah. Next question. Okay. So, machine learning data science role. How regularization helps in preventing overfitting in machine learning models. Can you describe the difference between L and 2? No, I can't. I do not have specific ML knowledge. I don't know. I do not know these things. Okay, so regularization. Lasso. That's penalty equal to absolute value. Rich. Okay, let's go. Next question. Okay, let me get back to it. Just wanted to check. Okay, so imagine you need to design an ETL pipeline to load data from relational database into data warehouse. What are the key steps in ETL process, or what challenging might you face? I was answering this question in the past, and you could see, like into that. And this was related of introducing the CDC to be able to remove the load from your relational database to be able to sort of like proper move the data into it. But we can actually, this time we can answer the different, because you not always integrate the CDC. So best approach would be integrate CDC. However, let's say we do not have CDC available to us, right? So we don't have the CDC available to us, so how would we introduce that? So design, right? What are the key steps in ETL process? The challenge might you face? First, let's wait. So first, create a query which would pull necessary data. Right. Now, 2, add this query to your ETL orchestration tool, like Airflow or something else. ETL orchestration tool, like, or something else. 3. So we reading data from the database, right? Now we have the query. So now we're basically reading from the database into okay, so let's go further. Query should store results in local file. Okay. 4, add new query, which would take local file and insert or copy data into data warehouse, right? Add data warehouse query to ETL orchestration tool. ETL orchestration tool. Okay, so when these are done, optional points, make sure that monitoring is enabled for the new pipeline. Feel free to explain your approach and let me know if you like the hints of guidance. Okay, what are the key steps of the process and what challenges you might face? So, possible challenges: your relational database is overloaded by your heavy queries. By your heavy queries. Okay, so now let's just go over, right? So you're building the ETL process, and what stuff do you need to do, right? So if you don't use CDC, then things pretty simple. You need to build a query. Now, a query which reads data and writes into the local file. Then you need to build a query which takes the data from the local file and then inserts data into your data warehouse. You will do the transformation either on reading or on writing or somewhere in the between. You could use pandas if you want somewhere in the between, it's up to you. Now the next step is you need to put all of these steps into your orchestration tool like Airflow or something else. And then eventually what you want to do, you want to basically like deploy this and make sure that you have like monitoring available to you, that yeah. Now the main things to look into is you need to make sure that your query doesn't kill your production database, right? So it shouldn't be doing it will be doing full table scans, but you just need to make sure that it uses some sort of like indices to select necessary data, and you should be good. Let's see how that goes. Yes. So far, so good. Just wanna check. Okay. Sorry, I'm just kind of like still getting my way around. Okay. Data engineering question. Imagine you need to design an ETL pipeline to load data from a relational database into data warehouse? What are the key steps in ETL process and what challenges might you face? So I have like a broader answer in here, but I will just go very short in this. So if you don't use CDC, the things which you need to do is you need to basically create a query which would read data from a relational database, would write into the temporary file. Then you would need to build another query which would read data from this temporary file and then write into your data warehouse. You could use a transformation either reading, writing, or in between using pandas. Finally, you need to put this two queries plus maybe transformation into your orchestration tool, and you should be good. Make sure you have like the monitoring is enabled, and the biggest challenge for this would be making sure that you do not break the production database. The way how you can achieve that if you're not using CDC is you should add the necessary indices which would make sure that they are only pulling the data which is needed, and that should be it. Thanks. Okay, that's good. I was a little bit busy because I was just creating the short what's the thing called, clip, right? So we can go to the next question. And I need to learn to answer these questions very fast, because like if I want to put anything into the shorts, it's just would be very, very slow. Okay, so that's it. Okay, let's get further. Okay, so next question. Let's keep going. Here's the next question. Big data technologies, data engineering role. Explain the difference between Apache Hadoop and Apache Spark when you would use one over the other in the big data pipeline. Right. Well, you should not use, I guess, Hadoop going forward. Just trying to figure out. Okay, I'm sorry, but like, what is expected answer for this question? Because both of them, Apache Spark and Apache Hadoop, is doing relatively similar things, where the Apache Hadoop is, okay, so Apache Hadoop is legacy system, and if you can, you should not be using it. Oh my God, it doesn't really hear me right. So let's put this one a little bit closer. I hope this will be better now. Can I somehow put this on top right here? Okay, so Apache Hadoop is legacy technology, and if possible, you should not use it. Right? Apache Hadoop is MapReduce engine, while Apache Spark contains and supports multiple ways of accessing the data. I guess you should always use Apache Spark over Apache Hadoop, unless you do not have a different way. Yeah, I don't know. I'll try to answer it this way. Yeah, I think this question is wrong. No one should be asking this question this way because it's... Yeah, but what happened if this doesn't fit in memory? I mean, when to use never, I guess. Okay. Next question. Given a table, order, columns order, customer order date, order amount, write SQL query to find the total order amount for each customer in the year 2023. Okay. Select select customer. Customer. Total order amount. Write SQL query to find the total order amount. Okay, sorry. So sum total order amount as total orders from orders where order date, let's use function year, equal 2023 and group by 1 or customer ID. What? All right. Okay. Sorry. It's usually integer. Yes, you're right. Correct. Next question. Explain the difference between precision and recall in the context of binary classified model. Oh, next question. And please do not give me data scientist questions. Okay, so let's move on. Database optimization. How would you improve the performance of the slow query in large relational database? Describe some common strategies. That's one, is a good one. First of all, know your data. When you know your data, then you know like you can do things. So make sure indices is in place for all the queries which can be found in the slow query log. Okay, make sure indices is in place for all the queries which can be found. Consider adding sharding and partitioning if available. I think that's my answer, right? So the question is, how would you improve your the performance of the slow SQL query in the large relational database? Describe some common strategies. And my answer is, make sure indices is in place for all the queries which can be found in the slow query log. Consider adding charging. Not charging, sharding, and partitioning if available. This will not be as slow. Okay, indexing, query optimization, right? Actually, you know what? I have a project which can generate some data, right? So I have this one. So now what we need to do, we just need to make sure that we do have the MySQL running. So let's go into my data engineering infrastructure project. And while we're here, we actually can search for the MySQL data. Not data, what I'm doing, MySQL Docker Hub, right? And let's start Docker. Okay, so MySQL, oh. I think this is fine. So let's get back into my, it's not responding, ouch. It's opening. Okay, so we have a bunch of things in here. Let's just add a new project. Let's call the new directory. Let's call it MySQL. Let's make a file, Docker compose. Right. Now let's add new directory. Let's call it data. This is where we'll be pulling our data. All right, and now let's just describe volumes and database MySQL, or we just call it MySQL service. Okay, password, this one is easy. Let's go with the root. And now DB name, okay. What else do I need to have there? I believe it's called driver local, and then driver options, type none, and then the location on the device should be just data, right? And now if I just go Docker compose, and let's go MySQL Docker compose up. Let's make sure we're loading the 8th service, and then this is the root. Okay, should it be MySQL data? Nope. Okay, so we need to can do it later as well. Okay, so we have a database up and running. Let's go now into our generator project. Right, I forgot to expose ports. Shoot. Okay, ports are added. This one is still initializing. Okay, we can stop it. Let's start it again. Let's use the database. And let's try to connect to so the database, I don't know the name, but this is root. Let's connect it, the database. So now we can go into our generator project, right? In the generator project, we have environment and we call the database test. Let's call it e-commerce. And let's call it scenario static. Scenario static. Now, will you be able to create okay, and now before us running this, right, we want to run the app, we want to run the scenario. Now scenario is right here static. Let's make sure that we actually generating everything for the, and what we want to do, we want to do -m manage load pi. Okay, so right, I left some trash in my right, all of this, and here is a trash which I should remove. Okay, and now it's access denied for the test, so it's not a test, is root. Will you be creating database? Nope. Okay, I want you to create database. How we can do that? It should be somewhere in here, I believe. On scenario initdb, create all. Okay, so SQL alchemy, how to create database. Create all, yes. Create database tables, but how do you create database? Yeah. Okay, so how do one create database using SQL alchemy? Is it possible? Oh. Okay, so database is MySQL. No, you're not helping. This is not creating database. Useless, right? Because I ask. Okay. And my question was how to create database using SQL alchemy, not tables. Okay, that's fair enough. So we're just doing this one. So self app db engine execute create database, and now the database name which we want to use is e-commerce scenario 1. Okay, and now let's execute the query. Fine, you win. Let's call it e-commerce. Let's do create database commerce for MySQL 8. Perfect. Now we can actually generate the data for our project. And now if I would say like, okay, let's refresh. We do have e-commerce with a couple tables, right? So getting back to the question about the optimization. So let's say we want to, like select star from orders, right? We don't have a customers, but that's, so we all want to select the e-commerce in here. So, right, so we do have, this is our orders, right? So let's say we want to, we have an ETL where we want to run data. So select, let's say we want to do, what do we want to do? We want to do the per day. So we want to have created at as, like the date. We also want to do is we want to count distinct ID, right, as order count. We want to also count distinct search ID. Amount of the searches was searches. And we also want to count sum total order total as total from orders group by date create at should be created at and what we also want to do, because we're running a batch job, right? We also want to have create by, right? And we also want to have a where clause where we say like look, so the date is equal 2024-01-01, right? So we basically like kind of like running the batch. Let's see if that would work. No, it doesn't work. Why doesn't work? Near ID. Right, count this. Ugh, my spelling tonight. Okay, so if we run again, right, we did have like a single row. Maybe not the best approach, right? But now let's go and explain this function, right? So this function, so right here, table type all, and it's used the, like where clause, and it's basically just selecting, like from 3000 rows. Now, let's look at this table and let's look at the indices it has. It has only primary index on the ID, and that's it, right? So now let's add index, and let's go to our, no, not here. So let's go here, and can I add an index through here? So alter table orders, add index on created add. Just simple query. Okay. Write me a SQL to create index. Yeah, okay. I guess you know your stuff. So create index, index name, created add on table orders, and the index name is created add. Not index name, but the column is created as. Perfect. Now I would run the same query. Possible keys is using this one. Right, so let's drop index created add. Right. Right. And instead I want to make it a date. Right. Can I do something like that? Nope. How to make index with a function? Is it possible? You see, it cannot be done in here. That's sad. Okay, so let's get back into here. So we cannot use this one. Can we just say, look, now I still want to use this as a date, right? Because this is sort of like an approach for me, because I want to drop all the time and be able to use this. Yeah, let's try to run this. Let's see if that will work. Okay, now let's select orders, created add, and now let's, so now we can use this and we can use this. And now if I also can use this. So now query, again, we have the same, like all types, all rows. Now let's create an index on this. And let's compare the numbers. And now we have rows number 14, which using the index. And so this is the cool thing about it. It basically knows that there is only 14 rows in this date, and it's pulling the data out of that. Like, we didn't really notice the difference between, like extracting the data out, but trust me, there was, right? So div index, and then let's drop index. I don't know if we would run again, like it's not really visible in here of how fast it is, but actually we can do something about it. So what we will do, we'll say like, hey, like let's generate even more data for us. And what I would be interested in is actually to generate even more data for just January, a couple days of January of 2024. No, we shouldn't, because it doesn't matter. Like, let's say we have 2023, and let's say, like we're generating for 2020, like 2023 for only 10 days, because the thing is just like, it's not that this January has a lot of days. Like the way how the database works, it needs to scan all the, it needs to scan all the data in it. All the data in the table, independent where the data is, when the data was originated. Okay, so it's still running. Let's see how many count orders. Right, we have like we have like 6,000. Okay, we can run again. Just like 10 days, like done. And now if we would run the query again, we have, like not really that much, which is totally fine. And then we can, let's go generate a day. Let's go to the minimum visits, and let's call that the minimum visits is actually 500, right? And then we'll just be running 10 of the, yeah. So now like for 10 days, 500. So that should increase the number into our, it's already 600, 640, 65, 666. Seven, still running strong. That's good. Oops. By the way, when you have this amount of data, it doesn't matter how you write your queries. It just fits into memory, and it's just like runs very, very fast. So it's actually, we don't need to do any of these type of the optimizations. It's all depends on the amount of data you have. So did we already drop the index? Okay. Now if I run the explain on this, just curious. So explain on this. Now as you see, it's like scanning like almost 10,000 rows. And now it's scanning, yeah. And then it says like it's filtered like, like a couple of results. That's quite take some time. Mm-hmm. Okay, let's try again. Still generating. So we add like 12,000 records. Again, because this data set is very simple, it doesn't really have a lot of information. It's kind of like will always be very fast. But this is what you should look like into the explain, right? So the explain, this represents the number of rows the query engine needs to scan. And if it basically says like, well, I'm not using, I have this type all, it means that I do the full table scan. So this is sort of like the slowest you can go. And let's wait for this to complete, whenever it will be done. Right. So what we're doing is we're running, generating the data, right? Let's see how that looks like. We're at 15,000 rows. This still doesn't have any impact, and nor it will, because, you know, like it's not really complicated one. While this is generating, let me just check a couple things on the side. All right, I need to shoot. Okay, it's done. Just a second. I need to do something. So back. Okay. So let's put this for next schedule. Now also need to delete this one. Sorry, I'm just distracted a little bit on the... Okay, good. So we're done generating, right? So we can run, again, explain command. We have almost 20,000 rows available to us. And, you know, like if we run the select statement, of course, it will not do anything significantly. It's just like, you know, like it's pretty fast, as I said, like it's, but the interesting thing is what you need to look is this one. So if I would create an index and I would run the select again, it's actually now only pulling like 27 rows from everything, right? So it's filtered 100%. So just think of this like you have an open file and it has like what was like 20,000 rows, right? And now if you don't have an index, it needs to scan each of this row to figure out what this needs to, and it just like it takes a lot of time to do. And of course 20,000 is a small amount of data, so we don't really care about that too much, but yeah, that's something worth keeping in mind. Okay, let's get back to the next question. And we good with this one, so next question. Cloud computing. You are tasked with moving large-scale on-premises database to the cloud. What factors would you consider, and what cloud services or architecture would you recommend for the scalable and cost-efficient solution? Okay, so this question is wrong because it concentrates on technology. However, the biggest problem with moving to cloud is not technology, it's people. When you move your data, then you need to move the ETLs. ETLs are written by the teams, but written by the people. Now we need to deal with people and find their time to move. I think this should be the actual answer. And sorry for anyone if you're looking, I'm just creating a short. We'll get back in a moment. Something like here. Migrating to cloud. Problem is people, not technology. Okay, let's create this one. Perfect. So just to reiterate what I was doing. So I have this question, right? So when you're tasked with moving a large-scale on-premises database to the cloud, what factors would you consider and what cloud services or architecture would you recommend for the scalable and cost-efficient solution, right? So first of all, the problem with this question is this question asks about technology, but the real answer and the real problem of migrating anything anywhere is people. You need to make sure that the people is on board and they agree with what you're doing. You need to make sure that you have a support from all the teams of what you're doing. Otherwise you will be stuck and it will be very painful migration. Now let's say you are all good, people are on board. So the next thing what you want to do is, like, what type of the database is this? Is it just like a database, MySQL? Then you might look into, you know, like AWS, what's the service, RDS, right? And just select the database out there and you should be done. You also can look into, you know, like if it's data warehouse, you know, like you could say like, okay, we want to build, you know, like a SQL and we want to go with the Snowflake or want to go with Trino, or you could like, yeah, so there's a bunch of like solutions how you can go with that. Now, another question is like, would you really would want to go to the cloud? Because if just for the data warehouse or for the databases, I don't know. I mean, it's, I guess you would, right? So next question. Oh, and that was me. That's good. Okay. So what are the key difference between SQL and NoSQL database, and what scenarios would you prefer to use NoSQL database or traditional relational database? There is no scenario where you should use NoSQL. NoSQL was created back in a day when people thought that the schema is hard and they need to have a database which would be schemaless. We do have databases from this time like Elasticsearch, which is not really a database, and MongoDB, which is database. However, I think they have a certain unstructured or like, you know, like semi-structured data usage cases, but in many cases, if you want to get really performance, you need to structure your data. I think that's my question, which could be totally wrong. Right, so data modeling. But that's the thing, like this is not, so like data modeling. So even in NoSQL, if you want to get the performance, you need to model the data. Like you cannot just expect to get the performance on the, you know, like on NoSQL if you don't model the data. Like all of these is, yeah, whatever, stop, just don't go. Okay, let's go, right? Let's go into like MongoDB, right? So MongoDB, great. Not pricing, I just want to go to the documentation. And then I want to go, okay, so Mongo. Documentation, so documentation here. Database manual. Okay, model your data. Why? So that's the thing, right? Like, why? Okay, so we need to go to different question about MongoDB. Why you would model data in MongoDB? This is okay. I'm sorry, Chad, but you're just doing stupid things. No, this is not how the things are. Okay. Yeah. Whatever. I lost my hope. Next question. I'll get back to you. And where do I put those? Mm-hmm. That's not fun. I was thinking I created a couple shorts, but looks like I didn't. Okay, do I have the last into? No, I don't. Well, it's fine. Can get back to it. Okay, so data warehousing. What is the star schema in the context of data warehouse, and how does it differ from the Snowflake schema when you would choose one over the other? So